Good day everyone! Before we start, I want to introduce myself. My name is Princess Andre Vikental and my partner.
And I'm Charlene Erastain.
Today we will talk about the mechanical and electromagnetic waves and its spectrum.
And how the parts of EM spectrum can affect us and their applications to our environment. So let's start with mechanical wave.
Mechanical wave is a disturbance that travels through some material or substance called the medium for the wave. As the wave travels through the medium, the particles that make up the medium undergo displacements of various kinds, depending on the nature of the wave. Let's proceed to the EM wave. So, what is the electromagnetic spectrum? All electromagnetic wave, also known as EM wave, travels at the same speed in vacuum, at 300 million meters per second, or 3 times 10 to the power of 8 meter per second. And also, it travels in a straight line in transverse motion. As the name electromagnetic waves suggests, it is both electric and magnetic in nature. Now that we've introduced what an electromagnetic wave is, let's now move to its spectrum. When electrically charged particles move, electromagnetic waves are produced. This wave travels outward or radiate from the charged particles. Visible light is an electromagnetic spectrum, as are radio waves, microwaves, infrared waves, ultraviolet rays or UV rays, and X-rays. All the different types of electromagnetic waves from the electromagnetic spectrum.
You can see that it ranges from longest to smallest wavelengths. The longer the wavelength, the lower the energy, and the higher the energy, the smaller the wavelength. Understanding the EM spectrum. Radio waves have longer wavelengths compared to other forms of electromagnetic radiation. This characteristic allows them to penetrate through obstacles such as buildings and atmospheric conditions, making them suitable for long-range communication. Microwaves find applications in cooking because microwaves cause the water molecules in water to vibrate, producing heat that cooks the food. Microwaves are also commonly used in wireless communication, such as signal transmission in cell phones. Infrared radiation is a type of electromagnetic radiation with wavelengths longer than those of visible light. All objects, including the human body, emit infrared radiation as a natural result of their temperature. The amount of radiation emitted is directly related to the object's temperature. Visible light plays a crucial role in our perception of the world, as our eyes are sensitive to the specific range of electromagnetic radiation. Sunlight is a natural source of visible light, and various artificial light sources such as light bulbs and LEDs also produce visible light. The interaction of visible light with objects determines their color, allowing us to see and interpret the visual world around us. Given the fact that it is present in sunlight, understanding and managing exposure to ultraviolet light is important, given its impact on human health and its applications in different fields such as detecting counterfeited banknotes. Proper protection such as sunscreen and sunglasses is recommended when spending time in environments with significant UV exposure. X-rays are commonly used in medical diagnostics to visualize the internal structures of the human body. They're also used for airport security because X-ray scanners are employed for security screening at airports to inspect the contents of luggage without opening them. Gamma rays are a type of electromagnetic radiation with extremely high frequencies and energies. They are a form of ionizing radiation, which means they have enough energy to penetrate through our skin. Gamma rays are used in medical treatments, various scientific studies, and understanding nuclear processes.
These waves impact our daily lives and the environment in positive ways by enabling technologies such as communication, medical diagnostics, and scientific research. However, proper precautions are necessary to ensure that exposure to certain types of waves, especially at higher intensities, is controlled to prevent harm to both people and environment. Balancing the benefits and potential risks is crucial in the responsible use of electromagnetic waves.
And that ends our discussion about the mechanical waves, electromagnetic waves, and its spectrum. We genuinely hope that you've learned something from this video. Bye!